In this video, we're going to cover 6.5 logarithmic properties. We'll talk about the product and quotient rule as well as the power rule. We'll expand and condense, and we'll talk about change of base. Let's start with the warm-up. We want to go ahead and simplify these exponentials. Okay, so remember that when two numbers are multiplied and they have exponents, those exponents are going to add. Okay, that is the product rule for exponents. Similarly, if two numbers are being divided and they have exponents, those exponents will subtract. We call that the quotient rule. Now, if we have a power to a power, they're going to multiply. That is the power rule for exponents. We have the negative exponent rule, which shows that we can rewrite any negative exponent as a positive exponent by writing the value as a fraction. So this would be 1/9. The same goes for the opposite. So now this would be 3/1 squared, or 3 squared, which is 9. Okay. Part 2 of the warm-up is converting to exponential form and solving. So here we are saying 2 to the power of 3 equals x. That's going to be 8. Here we're saying 2 to the power of 1 is equal to x, which is just 2. And here we're actually saying 2 to the power of -3, which is 1/8. Now, similar to the exponent rules, we also have the product rule and the quotient rule for logarithms. They essentially work the same exact way. If two logarithms are being added, they can be rewritten as a multiplication operation instead. So notice that we have m and n being added, and then they're combined as m times n. Okay, so here in this first one, we would have log base 9 of 9 plus log base 9 of x. We also know that this can simplify to a 1, which leaves us 1 plus log base 9 of x. That would be considered fully simplified. The next one has 3 things that we can separate. We're going to separate 14 from x from y. We're going to write log base 2 of 14 plus log base 2 of x plus log base 2 of y. There's nothing else that can be simplified or condensed here. Log base 2 of 14 is not going to be a whole number, so we would leave it as is. The quotient rule works very similar to the exponential quotient rule. So now you'll notice that when two terms are being subtracted, we can rewrite them as division inside the logarithm. So let's go ahead and do that with this next example. We're going to have log base 8 of 8 minus log base 8 of x, keeping in mind again that this first term will simplify to 1. So here's our fully simplified answer. Our next one is going to be log base 2 of 3 minus log base 2 of z. The first term can't be simplified any further, so this would be your final answer. Now let's chat about the power rule. The power rule shows that if you have an exponent outside on the far right of the logarithm, it can be brought to the front as a coefficient. So notice that this n ends up in front of the logarithm. Let's go ahead and expand doing the power rule. We're going to bring the 5 forward, and we'll have log base 2 of x. Not much else we can do there, so we will just go ahead and circle that. Here we have a square root, okay? That square root is going to be log base 3 of x to the 1/2, okay? Which means we can bring that 1/2 to the front and write 1/2 log base 3 of x. Not much else we can do there, so I'm going to leave it like that. Now let's combine all of the things, okay, and expand this expression. Okay, I'm going to go ahead and write the division portion first. So I'll say log base 8 of x squared minus log base 8 of square root of y plus log base 8 of z cubed. Okay, there's a lot happening there. Now I can continue by simplifying anything as needed. I can bring the 2 over to the front. I can distribute my negative and bring the 1/2 from the root. And I can bring the 3 down from the original exponent. This would be my final answer. Okay, we can also use these rules to combine logarithms. So in this situation, we would have log base 3 of 5 times 8 all divided by 2, which is going to be log base 3 of 20. I would stop there. That would be fully simplified unless you wanted to get a decimal approximation. You can also condense using all of these rules. So let's go ahead and take a look and see what we can do with this guy. I can bring the 2 back up as an exponent. I can bring this 1/2 over as a root, so let's start there. And then we have log base 3 of root y. Okay. Then these can be written as multiplication. This can be divided. So I'll say log base 3 of x squared times x minus 1, all divided by the square root of y. That would be my final answer if I am condensing this logarithm. Next, we have the change of base formula, okay? This is just useful if your calculator does not do bases other than 10, okay? It would allow you to rewrite your logarithm using base 10. Notice that this number is in the numerator, the base number is in the denominator. This can be plugged in, and you would find the solution just like you would if you were able to plug it in the traditional log base 5 of 26. Take a moment on your calculator to find that function and solve this logarithm. Now let's talk about 6.6. We'll go ahead and combine exponentials and logarithms and start solving equations. First, the warm-up. We'll go ahead and solve A, B, C, and D. And A, that is a quadratic, we can factor, so I'll jump right into it. We are going to start with x minus 3 and then x plus 2, set those equal to 0, and solve. We're going to end up with x is equal to 3 and x is equal to negative 2. Okay. I'm just going to slide down here and do C, and then I'll move over to B. So here we have a rational equation. I'll go ahead and multiply the denominator over on the other side and simplify. And now I'm just going to go ahead and solve, and I get an answer of x equals 2. Okay. On the next one, I have a logarithm. So let's take a look at what we've got here. So we have 6 to the 8th equals 6 to the 2x. So that's when I converted it to exponential form. My bases are the same, so I'm going to go ahead and get rid of them, and I get an answer that is x equal to 4. And then for this last one, I'm in exponential form, but I might switch to log form. So I have log base 6 of 2x equals log base 6 of 8. My logs match, so I can once again ignore them, and I get x equals 4 as my solution. All right, let's take a look at what we're going to be covering today. Now we can solve using like bases with an exponential equation. So that really means in A, we want to rewrite 81 using a base of 3. In this case, 3 to the power of 4 is equal to 81. That immediately tells us x is equal to 4. And the second one, we already have a matching base. So we can go ahead and ignore them and solve the exponents without any regard for the base. In C, we need to rewrite 8 using a base of 2. In this case, 2 to the power of 3. Don't forget to multiply out the rest of the exponent. Now we can solve the exponents on their own. I'm going to distribute the 3. And I'm going to get 5x equals 10, or x equals 2. The last one that we're going to do has 3 numbers. We're going to work with 3, 9, and 27. That means we need to rewrite 9 as 3 squared, and we need to write 27 as 3 cubed. From there, we have everything we need. We'll go ahead and write this out without the bases. Let's write this in standard form of a quadratic and set it equal to 0. And now we need to factor. If I want to factor, I'll go ahead and do this by grouping. I'm going to write 6x minus 1x minus 3. They have a 2x in common on the left and a negative 1 in common on the right. Okay, I'm going to move over to the side a little bit. I've run out of room, and rewrite this in factored form. 2x minus 1 times x plus 3 equals 0. That gets us x is equal to 1/2 and x equals negative 3. We're going to have 2 solutions to this equation. Next up, we also can solve exponentials using logs, so we can kind of convert between the two if there's ever a situation where one is not convenient for the other. For example, 4 to some power is equal to 17. Sure, I believe that, but what number could that be? We know it's not a whole number. So in this situation, it might make the most sense to simply solve it as a log and plug this into your calculator, which will get you 2.044. As a reminder, if you have to use the change of base, this would be log of 17 divided by log of 4. Again, some of you might need to do that if your calculator doesn't allow you to change the base. Some of you can just solve as is. Let's do the same thing here. We're going to go ahead and write log base 10 of 20 equals x. This one everyone can do as is because it's base 10, and you'll get 1.3. Next up we have e. E means that we are going to work with natural log instead. So natural log of 0.5 is equal to negative 0.4t. We can divide by negative 0.4, and we will get t is equal to 1.73. You'll notice that most of the time our answers will be decimals. That is to be expected when we're working with logarithms. It's rare that we end up with a whole number. Now, our last question is going to require adding logs on both sides. Okay, so we'll go ahead and write this as log base 10 of 5 to the power of x minus 2 and log base 10 of 4 to the power of x. If we bring these to the front, we have x minus 2 times log 5 equals x times log of 4. Now, we can calculate log 5 to be 0.699, and we can calculate log of 4 to be 0.602x. At this point, it's just math. We'll distribute the 0.69 to both terms, and we will solve. We'll bring the x's together, and we're going to end up with x is equal to 1.44. All right, the last portion is for you to practice. I recommend pausing the video at this point and working through some of these, and when you're ready to start the video again and go through these with the video. All right, on this one you'll see that they have logs on both sides. If they have a log on both sides that match, we can ignore them and just solve the inside of the log. So that'll be 14x equals 9, or x equals 9 over 14. I'm okay with leaving it as a fraction. I prefer it. In this situation, we have logs being subtracted and they match. We have a log on both sides of the equation. Similar to before, we can go ahead and get rid of the logs and solve them without. I'm going to multiply the denominator on the other side. I'm going to find that I have a quadratic. X squared plus 4x minus x minus 10 equals 0, or x squared plus 3x minus 10 equals 0. If I factor, that'll be x plus 5 and x minus 2 equals 0, or x equals negative 5 and 2. Both of those solutions will work. So let's move on. Now we need to go ahead and simplify a little bit before we do anything else. So I'll go ahead and bring that 5 over by subtracting it. And now I can rewrite this in exponential form. And if I divide by 3, I'll find that x is equal to 12. And then finally, our last question looks slightly different than the one from above. Notice that there is no log here, so go ahead and combine the left using a logarithm. So we have log base 3 of x minus 5 times x plus 3 equals 2. So now we can rewrite this as an exponential. And you once again have a quadratic. So we'll have x squared minus 2x minus 15 equals 9, or x squared minus 2x minus 24 equals 0. If we factor, that will be, let's see, negative 6 and plus 4. And solving will get us positive 6 and negative 4. Okay. That is how we work with exponentials and logarithms when solving equations.